Hi and welcome to Electrical Engineering Planet. In today's video we will create a circuit that has 3 induction motors that will work alternately. Every motor will work for 8 hours every day. So they will work one by one. The first motor will start working for 8 hours. After 8 hours it will stop and make the second motor to start working, and the first motor will rest. After another 8 hours, the third motor will start working and the second motor will stop. After another 8 hours, the first motor will start working, and so on. So here, let's start creating this circuit. Here from our Electrotechnical IAC library, we will choose power. To create our power circuit from energy sources, 3-phase power, we will bring our 3-phase power source. Now from protection, let's choose a 3-pole circuit breaker. Now from contactor poles, I will choose 3 different 3 poles contactors because we have 3 motors. So let's bring the first contactor here, and then the second one, and then the third one. Now every motor has a protection, so I will give every single motor a protection against thermal overload. So let's bring here 3 thermal overload. Now let's choose our motor. From motors, 3-phase, asynchronous or induction motors, we will choose this 3 ends induction motor. I can make another circuit for star delta connection for every single motor, but here I will make it simple. I will just have a motor that will work as direct online method. So let's bring here the first motor, the second motor, and at last the third motor. Now let's connect our power circuit. Here from 3 power wires, I will start creating my circuit. Here from the 3-phase to the first circuit breaker, and then to the contactor, then to the thermal overload. Let's rearrange it a little bit. Then from the contactor to the thermal overload, and then to the motor. Let's connect the second circuit and the third circuit. Here, after the circuit breaker, I will connect a 3 power wires to the second and the third contactors. And now our power circuit is ready. We have a 3-phase power source and the circuit breaker. When we close the circuit breaker, the power will be on those 3 contactors. Any one of those contactors will start working. It will make this motor to rotate and this thermal overload to protect it against thermal overloading. Now let's start creating our control circuit. Return back from power or energy sources. I will choose a single phase power source and let's drag and drop it here. Now from control protection, I will choose a single pole circuit breaker. Let's drag and drop it here. Now from switches, I will choose a normally closed push button. After that, we will create 3 series thermal overload normally closed contacts to protect it against thermal overloading. So double click on the first thermal overload. From plus here, I will choose a normally closed contact. Press OK. Let's drag it here. Double click on the second thermal overload, add another normally closed contact, press OK. Let's drag and drop it here. Also the third one, add another normally closed contact and drag and drop it here. So any of those thermal overload will have a problem, it will make the circuit to stop and we have to investigate the problem. Also, we can create a lamp for every normally or for every thermal overload to investigate or to understand which thermal overload has a problem. So we can go to this specific motor and start applying a maintenance on it. Let's add here normally open contact from every thermal overload. And I will use those normally open contact with a lamp, 3 different lamps. Those lamps are the fault lamps. So let's drag and drop them here. And here from signaling devices, we will choose 3 different lamps. This is the first lamp, which indicates a fault in the first thermal overload. This is the second lamp for the second thermal overload, and this one for the third thermal overload. I will connect the wires at the end. Leave it as it is here. Let's return back to our circuit now. Here, as you can see, we have our circuit breaker and then the normally stop push button, and then we have 3 thermal overload normally closed contacts to protect our circuit. Now I will bring from switches a normally open push button or start push button to start our circuit. Here actually from contactor coils we will bring 3 different coils. The first coil is related to the first contactor, and the second one for the second contactor, and the third one for the third contactor. So let's drag and drop here 3 different contactor coils, and here for the first contactor coil I will make a latch from relay contact. Here I will make a latch or holding contact so that when this contactor is working and this coil is working, we will make a latch. Now let's rename every single contactor here. Let's call the first one as KF1. So we have linked it to this coil. Let's call this as KF2. Press OK. Let's call this as KF3. And now perfect. Here this contact I will call it as KF1 because it's a latched contact from it. KF1. Perfect. Here actually, when KF1 is working, I want another timer to start working, because this timer will be responsible for making this second motor to start working after 8 hours, and then we will stop this first motor. So here from relay coils, I will bring this timer. Let's drag and drop it here. This will be the first timer, and this one will be the second timer, and then this will be the third timer. Here every timer I will double click on it and choose from electrical characteristics to delay on operate, and here we have to put 8 hours. So from each or hours I will put it here 8. But when we will simulate our circuit, we will not wait 8 hours to be sure that the second motor will start working after the first motor. So here for our simulation, I will just put 10 seconds because I want to see it change fast, because I want to see the results fast. So here for the second also timer, delay on operate, let's check it, and here 10 seconds only. But in real, we will choose it 8 hours. The third one, let's check on delay on operate, 10 seconds, and our circuit is perfect now. Now I want this motor to be working, and after a time, I want the timer to make a signal to make this contactor to start working. So we will use a normally open contact. This normally open contact here, I will make it related to this timer KF4. So when this timer will start counting, it will be open. When it reaches to the time that I have set it, it will close this contact, which will make this contactor to start working. But I want also here a latched contact from this contactor. So let's bring a normally open contact and let's link it to KF2. Let's do it again here. I will make this normally open contact to be related to this timer, which is called KF5. And another normally open contact which will be holding or latched contact and related to KF3. No, KF3, not KF2. It's okay. And perfect. Let's now connect our circuit. Here from power wires, this is our circuit breaker, and then the emergency stop, first thermal overload protection, the second one, and the third one. And here let's connect our latched contact to the timers, and here to the start push button. We forgot something now. Here, as you can see, when this timer will trigger a signal, it will make this contactor or coil to start working. And after a time, this timer will make this contactor to start working. But after a time, this timer, I wanted to make a signal return back here to make the first motor to start working again. So I need also a normally open contact that is linked to this KF6 here to make the first motor to start working. Because if we didn't do this, the first motor will start only the first time when I press on this push button. It will work, and after a time this motor will work, and after a time this motor will work, and it will never stop. It will start working. But when we put here this normally open contact, it will make this contactor work again. Now let's connect it to our circuit. Here, as you can see, it's KF3 is parallel to this timer normally open contact, and those are also parallel, and those are also parallel. Here, let's connect the neutral points here. Here, when I press this push button, the first contactor will work, so our first motor will work. After a specific time, this timer will give a signal here to this or to the second motor to start working. But actually, the first motor is still in service also. I want this motor to get out from the service, to stop. So I will put a normally closed contact here, which is related to this contactor. So when the second contactor is working, the first motor will stop. Now, when this motor is working after 8 hours, this motor will start working. So I want, when this motor start working, this motor to stop. So I will put another normally open contact here to open the circuit when this motor is working. Let's link this contactor to this normally closed contact. And here, as you can see, the names of the contactors has been changed. It's not a big problem actually, but this happens always when you remove or delete some wires. I don't know actually why. The names of the contactors start to be changed, but every contactor, coil of the contactor, is still linked to any point that I have linked to. So it's not a big problem actually. Now this motor is working now. After 8 hours, I want this motor to start working and this motor to stop. So this motor will work, but this motor will not stop. I will put here a normally closed contact related to this contactor, KF7. Now it's named KF7. So when this motor starts working, it will make this motor to stop. Now let's link the lines, power lines. Also, I will add 3 lamps. Every lamp is related to a specific motor. So, from signaling devices, let's add 3 lamps. The first lamp related to motor number 1, the second lamp related to motor number 2, the third lamp is related to motor number 3. And let's connect it in parallel. Here we have the 3 signals, which is related to a trip, thermal overload trip. Now I will connect it to the power source, Here FC1 is related to the first lamp, FC2 is related to the second lamp, FC3 is related to the third lamp. And the 3 lamps will be connected to the neutral. So we are connecting them to the main neutral. Now our circuit is ready. So as you can see, this is our power circuit. We have 3 motors, motor number 1, motor number 2, motor number 3. And this is our control circuit. This circuit is related to working motor number 1, and this motor number 2, and this motor number 3. This is related to an indication for any trip related to thermal overload. If our first motor has a thermal overload, it will light this lamp. This is for the second motor, and this for the third motor if it happened that has a thermal overloading. Now let's simulate our circuit. Let's close the main circuit breaker and the control circuit breaker. And as you can see, the 3 motors is not working, still not working. But when I press this push button, the first motor will start to rotate. And here the timer is working. After 10 seconds, it will send here a signal to make the second motor to to work and the first motor will stop. It will not stop actually suddenly or immediately because of the inertia. The second motor now is working. After 10 seconds it will send signal here to make the third motor work, and its lamp is working also. So this motor will start working and those two motors must be stopped. But as you can see, it has a high inertia, so it will not stop suddenly. Now, after 10 seconds, the first motor has started again. Now, if we want to simulate it better, we will change the inertia here. I want to make the inertia to be less. So let's double click here on every motor and let's change the friction coefficient. I will change it here to 0.0001, and this I think it will be sufficient. And let's check on it. The second motor, let's check on it and change it to 0.0001. The third one, let's change it to 0.0001. This will make the motor to stop faster. Let's simulate our circuit again. Let's close the breakers. Still nothing happened because we didn't press this push button. Let's press it and the first motor will start working and its indication lamp is working also. After 10 seconds, it will send a signal to make this contactor to start working. So the second motor will start working and the first motor will stop. After 10 seconds, it will send a signal to make this contactor, which is related to motor number 3, to work, and this motor will stop because of this normally closed contact. So as you can see, the third motor now is working. After 10 seconds, it will be repeated again. The first motor will start working again and the third motor will stop. As you can see, it has been working and this one is stopped, and so on. Of course, in practical life, we will make those timers on 8 hours. We will adjust it on 8 hours. So every day, one motor will work for 8 hours, then the second motor for 8 hours, and then the third motor for the last 8 hours in the day. That was it for today, and in the next video we will learn how to create a photocell sensor circuit. So please consider subscribing in Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.